Okay, this is Matthew Goodenough in ENGR-120 Lab 3, and this is section MO2. And right now I got the first circuit set up, so we're going to measure the voltage from our voltage source and our two resistors connected in parallel. So when we do this, they should all be the same. Let me do that real quick. Here's our voltage source, DC settings, DC current. So right now I have it set to about 7.82 volts. I'll throw it on the resistors here. We get 7.82 volts as well, and we do it to the other one, we should get the same reading. So it flows in our parallel circuit and we get 7.82 volts, and that is correct because it's a parallel circuit, so the voltage will be the same. Here I use different values. I'm just using this to demonstrate the lab. The voltage of the circuit are equal to each other. Voltage in parallel circuit voltage is the same for all elements. Now to measure the current running through there, we have to switch our multimeter to milliamps. Let me take these off as well. Let me get that set up real quick. Switch our milliamps on here, we go to DC milliamps. So now we have to switch our leads, because now current's gonna flow through our multimeter and into the circuit to read our current measuring out. And let me disconnect this so we don't short circuit anything. And let me set up the circuit real quick. So to set up the circuit to measure milliamps, we have to break the circuit and make it an open circuit. So we just take out that wire, unplug your power supply, and then we put our positive lead on our positive wire, and then we also put our negative lead on our resistor on the front end. So it's going to go to positive to negative, right? And then once we plug in back our power supply, it should read our milliamps at the current source. And it should be the same for resistor 1, current 1. And yes, so we get our milliamp reading. I use different voltages, but for my lab experiment, I got 9.007 milliamps when I did the same procedure. And now we'll measure the same resistance. We'll measure the amperage for the resistor number 2. And it's the same procedure. And then once you do it, you unplug your current source. You plug back in that voltage for the first resistor. So now we plug that wire back in, so it's a complete circuit again. And then we gotta break the same wire for the other side as well. So we move our power supply wire down. So now here, it's gonna move through the other resistor. It's the same procedure. We break the circuit for the second wire, plug back in for the original, and we have the same circuit, and it should read our milliamps once we plug back in our power supply. So once we plug in our power supply, we get a milliamp reading of 1.553, and again, I used another one, but mine came up to 1.773 milliamps. And then you calculate your percent error for your actual and your given. Mine was 0.98 kilo ohms. For the resistance, we use Ohm's law to find that resistance value. I had a percent error of 0.2%, so very low percent error. You do the same, you calculate both resistance from your resistors. My resistors I chose was a 1 kilo ohm and 5 kilo ohms. And we could do that as well. I'll show you the resistance. Sorry, I didn't include that, but that's no problem. We can fix that real quick. The main goal of that procedure was to understand how a parallel circuit works and to find our values of our resistors, and it's known from known current and voltage, and the percent error within our resistors. And then if you want to go to resistance, we just go back to our millimeter, all the way back down. We go to ohms now. Now we're allowed to measure our resistance in the resistors. So and don't forget to switch the leads and power it off, because we were going through that. Now we gotta go back to the resistor to get the reading. It's basically making it. So you switch your leads and then you go back to your ohms. Now we should get a resistance reading. 0.8, it's almost 1 kilo ohm. Now we measure our second resistor, and it goes back into our multimeter. 0.82 kilo ohms. Hold on. There we go. Now we got a better reading. 5.013 kilo ohms. It's better to take it out of the circuit so it doesn't read any other resistance. That was for our first lab circuit. Now let me build the second one of the overload. Now let me build it real quick. Okay, for our next circuit, it's gonna be an overload circuit, just like that one. And the two resistors I'll do each one, because we need 4 resistors. I'll measure the ohms real quick. $326.1 kilo ohms, and that was the required resistors. And then the other one, it's about 5 kilo ohm resistor. Those were the 4 resistors required. Let me set up the circuit. Sorry, is it taking so long? This was the long circuit. I'll just demonstrate and explain what I got from my results. Try to hurry it up. So here now I made my own overload circuit at 3.7 volts. So we will record our resistant values, which was right, 326 kilo ohm. There's 2 of those, and 2 of the 500 kilo ohm resistors. There's resistance 1, resistance 2, resistance 3, resistance 4 with different values. Then we plug in our equivalent resistance from our parallel circuit. I found that to be 98.76. Record the measured values of voltage with load and with no load. So with load I had about 3.59 volts. And when you do the load, to measure the voltage, you just do it from here. And then your reading. So here I did a little bit bigger value, but you could see the voltage decreased from our voltage source due to our overload. So when you take that off, you have the actual voltage. So the voltage reading without our overload would be 3.72 volts. And then finally, find all the equations. My RS was 1.86 kilo ohms. My power was 7.209 milliwatts. So power and my voltage, the voltage was decreased 3.667 volts. And that was my overload circuit, and that should conclude my circuit for lab 3. Thank you for tuning in. I know it was a long one. Thank you. Have a good day.